10 thermometer reads 7 degrees centigrade. It means temperature is a 7 degrees centigrade and the pressure is a 70 centimeter of mercury. And at the bottom of mountain it reads 27 degrees centigrade, but pressure is a 76 centimeter of mercury. And we want to find compare the density of the air. Then we know according ideal gas equation PV equal to mu RT. Then the number of mole is equal to mass of the gas divided by molecular weight. That's why P is equal to density upon molecular weight into RT. So the density is proportional to P by T is proportional to density is proportional to P by T. P is a pressure, T is a temperature. So density at the bottom to top or a top to bottom. Suppose density at the top of mountain to the bottom of mountain is a pressure at the top and temperature at the top, pressure at the bottom and temperature at the bottom. Top per pressure 70 centimeter of mercury and the temperature is at the bottom is a 273 plus 27, it is 300. Temperature at the top is a 7 degree, means it is a 280, and the pressure is a 70 की जगह 76 centimeter. So it is a 21,000 divided by 280 into 76 is equal to 0.9868. That is the ratio of the air density at the top of the mountain to the bottom of mountain. A bubble of a volume is a 20 formed at the bottom of the lake which is at the 31 meter deep. Temperature is a 7. When rises, the volume will be changed and the pressure of the atmospheric is at 76. It is almost 76 centimeter, means almost 10 meter of water. So the surface पर 10 मीटर वाटर है तो बॉटम पर जो वाटर है that is almost 40 meter. So we can say 40 meter pressure, 40 meter water column, because 10 plus 30 deep. So you कहते हैं कि number of mole inside the bubble is a mu equal to PV by RT. Then P1 V1 by T1 is equal to P2 V2 by T2. Then pressure at the bottom is a 4 times of the atmospheric pressure. The volume is a 20. Temperature at the bottom is a 280, means 7 degrees centigrade plus 273. And pressure at the top is a 1 atm and the volume change होगा. Temperature is a 27 के according 300. इससे वॉल्यूम कैलकुलेट करें तो इट इज़ 80 मल्टीप्लाई बाय 300 डिवाइड बाय 280, that is equal to 2400 divided by 28. So that is at 85.71 centimeter cube. So answer is 85.7 centimeter cube. This problem, a vertical hollow cylinder of a total height is 1.52 is fitted with a movable piston of negligible mass and thickness. The lower part is a cylinder contains an ideal gas, and the upper half is filled with the mercury. The initial half is filled, and the cylinder is initially at the temperature of 300. Temperature reached किया, half of the mercury comes out. It means according problem and according given diagram, if this is cylinder, that is a piston which divides into two equal parts, and the height is a 76 centimeter, and that is a 76 centimeter. It is ideal gas. When it is heated, suppose the final temperature जो भी होता है इसका T, but उस टाइम आधा मर्करी बाहर निकल जाएगा. So the remaining is only 38, and the height of the gas is a 76 into 2, 152 में से सब्ट्रैक्ट करता है तो it is a 114 centimeter, and the level of the mercury is only 38 centimeter. Now initially हम यूँ कहें कि number of mole, suppose गैस का म्यू है तो अभी भी number of mole म्यू, it means a P V1 upon RT1 is equal to P2 V2 upon RT2. Number of mole of the gas or mass of the gas is conserved. अब इनिशियली प्रेशर की बात करें तो इस जगह तक प्रेशर P0 है, इस जगह प्रेशर गैस का जस्ट ट्वाइस ऑफ P0 हो जाएगा. इस जगह P0 है, हाफ प्रेशर होगा, इट मीन्स इस जगह प्रेशर 3P0/2 हो जाएगा. सो P1 इज अ ट्वाइस ऑफ P0 and it is a 3/2 times of P0. Volume of the gas is a 76 into area of cross section, that is divided by temperature is given, it is a 300, and now the volume of the gas is according, it is a 114 into cross section area that divided by the final temperature is suppose T. दोनों को इक्वेट करें हम, then it is a cancel with this, and the T equal to 3/2 114 into 300, and that is divided by 2 into 76. और यदि इसको हम सॉल्व करें तो इट इज़ अ 337.5 Kelvin. So the final temperature of the gas is a 337.5 Kelvin. प्रॉब्लम, ए क्लोज्ड कंटेनर, एक कंटेनर जिसका वॉल्यूम गिवन है, टेम्परेचर गिवन है, प्रेशर गिवन है, और दैट इज़ अ, इसमें जो दो गैसेस हैं नियॉन एंड आर्गन, और टोटल मास भी गिवन है, दैट इज़ 28. सो अकॉर्डिंग आइडियल गैस इक्वेशन, प्रेशर वॉल्यूम इज इक्वल टू टोटल नंबर ऑफ मोल इंटू R into T, number of mole of the neon plus number of mole of argon. Pressure is a 10 raised to power 5 and volume is the 0.02, and that is equal to the number of mole of the gas neon and argon. R is a 8.314. It is 8.314 is R, and temperature is given. Temperature is a 27 degrees centigrade, means 300. And the number of mole of the neon is, suppose the mass of the neon gas is a M, then the mass of the argon gas is a, total mass is 28, so it is 28 minus M. ये नियॉन का हो गया, नियॉन का मास सपोज M ले लिया, तो आर्गन का 28 minus M. Now number of mole of the neon is a M divided by, and 28 minus M divided by, what is the नियॉन का मॉलिकुलर वेट जो है वो 20 है, इसका 40 है. नाउ इट इज़ 2 into 10 raised to power 3, 2000 is equal to M by 20. प्लस 28 माइनस m बाय 40. इन दोनों को मल्टीप्लाई करेंगे, इट इज़ 2494.2 and this term is a 0.8. so 0.8 इक्वल टू, इस जगह 40 से मल्टीप्लाई कर लें पूरी टर्म को, देन इट इज़ a equal to m plus 28 minus m. Therefore m is the mass of the neon, is a 32 minus 28, so it is a 4 gram. And the mass of the argon is a total mass is a 28, so 28 minus 4, it is a 24 gram. These are the required answer. Mass of the neon is a 4 gram and mass of the argon is a 24 gram.